So, welcome to this episode of Climate Verso. Climate Verso is a unique new podcast where we are inviting climate experts with different points of view to talk to each other. And my name is Ned Komar, and I put this podcast together because, in my perception, there's a severe lack of conversation in the climate world between the people who think that climate is a big problem for humanity and other scientists, et cetera, who are less concerned. And generally, I'm personally not concerned about the climate issue, but I don't trust that because I'm not a scientist. So I really want to hear the scientists argue because I feel like, at least for me, I can really start to get a better understanding of how this issue really works when I get to hear a robust argument. So that's what this podcast is about. And for this episode of Climate Verso, I've invited two guests. I'll call them protagonists. One is Dennis Garrity. He is a longtime agricultural scientist, and Dennis has developed a very strong interest in the climate issue. And I'll let Dennis go into way more detail, but Dennis is part of an organization. I think he runs the organization that is involved in trying to find uh, a, a solution to global warming, to climate change. And then I also have Mark Blumler, who's also an agricultural scientist. And Mark, I may be being a little bit vague there. You can be more specific when you introduce yourself. And Mark has also developed an interest in the climate issue. And I put Dennis and Mark together on this episode in part because they have similar backgrounds as agricultural scientists. And they're both really interested in the climate issue, but coming from different points of view. So Dennis, I would say, is definitely concerned that the Earth is getting too warm. Mark seems to be less concerned about that. Okay, so Dennis, I'm going to start with you because, in a sense, I'm going to start with asking you to introduce yourself, um, and just one more quick thing, which is I'm really interested in what you're trying to do, and I'm also interested in having Mark kind of play devil's advocate, and so that's kind of the what I think might happen on this episode. And one more thing about these episodes is we never know how they're going to go. This is a conversation, and the guests, the protagonists, have a lot to do with where this conversation goes. Okay,
Mm.
Dennis, take it away. Thank you.
Okay, well, thank you, Ned, and it's going to be a great experience to join you two gentlemen on this conversation. I think that quite clearly we all are on a personal journey to understanding the nature of climate heating and its implications. I mean, everyone is on this journey that is even vaguely aware of the context of climate change. My personal journey started way back when I was in high school, and I read a seminal book on the global food crisis, which was occurring back in the 1960s. There was a very serious lack of food production capable of feeding Asian populations, particularly India, Indonesia, Philippines, etc. And this book raised the opportunities and the dilemmas of solving that crisis. And I was galvanized as a high school student with this problem. And I was always interested in agriculture, farming. My family had a dairy farm south of Cleveland, Ohio. And I began to realize that you could put science and farming together into a very stimulating career focused on solving the global food crisis. And so I went down to Ohio State, majored in agriculture, went over to India for a full year of my curriculum at the Punjab Agricultural University, where I was introduced to the real situation of a developing country which was suffering enormous food deficits at that time. In fact, the U.S. was transporting 20 million tons of wheat to the to India every year to keep people alive. I had such an experience there that, of course, I just focused my career on the development of small farm cropping systems in the tropics to help make life a little easier for millions of farm families in Africa and Asia, and to overcome this food crisis, but also to enable farm families to get ahead. To build assets and to solve the kind of problems that very poor families have to cope with every day. So,
Interesting.
I worked on that for many years, and that carried me to the World Agroforestry Center eventually, where I was director general and leading a global research institute trying to solve these problems. And I became particularly focused on the challenges of restoring degraded lands. There's about 2 billion hectares of degraded land around the world, particularly in the tropics. And there are tremendous opportunities for restoring the health of these lands, both degraded, managed ecosystems and unmanaged or natural ecosystems. And that really caught my passion. When I retired from that position, I developed an organization called the Global Evergreening Alliance, which has flowered into a coalition of 106 major organizations focusing their attention on land restoration. And I started to get very interested in the climate solutions because the restoration of these managed and natural ecosystems could have enormous impact in terms of drawing down and storing carbon in terrestrial ecosystems. In fact, we did
Dennis,
a
let me
white
y-
paper on that.
Dennis,
Yeah,
let me just interrupt you for a sec because we're getting into a lot of technical details, and I want to make sure the audience
yeah.
follows. So, for example, you're talking about real simple. You're talking about agriculture, and you shifted into climate and how you see that connection. And actually, that's a great start for an introduction. I'm clear that one of the questions I had is what was the time frame? So you started, you got interested in agriculture in the 60s, but when was it that like give me just a what was the year that maybe for the first time you said there's some connection between agriculture and climate?
Change. That was 2001, Ned, when
Okay,
I had just become director general at the World Agroforestry Center in Nairobi. And we had a global working group on climate change where I began to look at the results from scientists all around the world on what was going on in terms of the impacts of climate
got it.
change. Yeah. So
Okay, so
2001.
I'm just gonna I'm gonna rudely interrupt you, Dennis, because I'm sure there's a lot more that we're gonna learn about you and your career, and I just want to get Mark involved in the conversation. And one of my jobs is to make sure that since we're all in a sense, I like to think of myself as a climate nerd, right? So, um, like I understand climate technical terminology, right? But I'm trying to appeal to an audience that doesn't have to have that level of understanding. So, and you started talking about the a technical connection between carbon and agriculture, and so far we haven't even yet defined what does carbon have to do with climate. So
Uh,
let's just pause now, and what we're gonna get we're gonna have plenty of time to get into all of that. So let's just pause now and give Mark a chance to say hello and tell us Mark, how did your interest in agriculture uh, get lead to you getting also interested in the climate issue?
Okay, thank you. Thank you, Ned. Thank you, Dennis. One thing I just want to say off the top is, wow, getting to go to India, to Kenya, all of that. I mean, foreign countries are just such amazing experiences, right? I'm a little bit envious because I have a very delicate digestive system, and I can't go to some of those. India's probably out for anyway, but, all right, and then, my name actually is Blumler, not Blumler. I probably in Germany, it probably would be Blumler, but, not that that matters, and, I'm not sure I'm really an agricultural scientist. It's one of the things I do, agriculture, but, as a geographer, geographer is just good, it's anything you can put on a map, and then the explanation of that. So we have a real tendency to have sort of very diverse interests, and I certainly fit that. So let me back up. I feel that I was lucky that I was kind of accidentally raised outside the Western thought system, not completely, but I was kind of left on my own and became a Taoist when I was 12. And for a long time, I actually thought I was not a Western thinker at all. But I've come to realize that's not quite true. I'm more of a hybrid between Taoism and, well, like evolutionary theory, for instance. There's no notion of evolution in Taoism. So I'm kind of a mixture. I got in, I actually, it was 1976 that I fell in love with wildflowers out in California, and I went back to college. I'd been a dropout, to learn about wildflower ecology. So I was really an ecology major. But actually, the year after that, I think, is when I joined the Hunger Project, which, that was based in part on food for a small planet, right? Yeah, Dennis is nodding his head. He knows. Yep. So I have had that interest. I mean, I was just a volunteer. I was I wasn't more than that, but it was a really amazing experience. Anyway, but my primary, my research and my studying was really all plant ecology. But since I ended up in geography for my PhD, I TA'd meteorology, and then, when I came to Binghamton which is where I'm a professor, SUNY Binghamton, 1991, I came here, so I've been here just about 35 years and teaching weather and climate change the whole time, among other things. And, so I came here really a plant ecologist slash biogeographer, but, the program I'd gone through, there were all these, political ecologists and so on. There was one guy in particular who was all about what he called nations versus states, by which he meant, essentially defending tribes of various sorts versus, state governments. And so there was a lot of food and ag related and third world related stuff going on in my program. But anyway, when I came here, there really had been no talk about climate change, I don't think, at Berkeley, which is where I'd got my PhD. And when I came here was right about when it was really hitting the Envi programs hard. And so that's really when I first really got involved, was that probably that first year teaching here. And and then I guess the other prong in terms of my background is there was a star here, one of the few stars really that Binghamton has, is a cultural evolutionary biologist. And I really look at a lot of all these issues where you get polarization and so on. So much of that reflects, sort of our inability to have discourses that work, I guess you could say. So much of that reflects our evolutionary history or cultural evolutionary history. And so I have a tendency to look at at all of this from that point of view too. So there may be some Taoism coming up, there may be some science coming up, and there may be some cultural evolution coming up in terms of, my interactions here with you. So
if you could, I'm clear that Dennis is, Dennis, you'll have plenty of time to go into detail about this, but I'm clear that Dennis is concerned about the Earth getting warmer, about climate change in general, about the relationship between climate change and agriculture. Mark, if you could just say where are you coming from? Like, are you worried about climate change? Um, let's just ask that simple question.
Well, I would have let me put it this way, when, the ozone destruction thing hit, that was definitely something to worry about. Short
And that
term,
and that was
because
about 1980, I think. Is that around the
it
time?
was, well, I think the agreement came when George Bush was president, but yeah, for a few years leading up to that. And, we almost didn't learn in time. We were just lucky that there were 2 scientists who were like, "Huh, those chemicals getting up there in the they could actually maybe just," no, it was just if those 2 guys hadn't been around independently having the thought that, these chemicals might be destroying ozone, we might not have found out till it was too late. So my primary concern tends to be about unanticipated
Okay.
consequences.
Wait, oh, but
And
hold on, Mark.
yes, and there could
Say
be
more
some
about. Okay, I'm sorry for
with
interrupting.
climate
Keep going.
change
Keep going.
with climate change, we don't, there's so much nonlinearity in the climate system that, there's a top geophysicist, who back probably around 2000, maybe in the 90s, I'm not sure. He proposed that global warming might lead to an ice age. He later changed his mind about that, but he was like a top guy, Wally Broker. And, that's the that's the kind of thing that, I mean, an ice age would be terrible for humanity. It'd be absolutely
Wait,
terrible for
I'm a
humanity.
skier. I would be thrilled. Oh my
Yeah, except
God,
you wouldn't have
skiing
any
all year round? Come
except you
on.
wouldn't have any food. You can't feed very many people, agriculture is pretty much impossible in an ice age climate, so yeah.
Well, Dennis, I actually I'm going to jump ahead. I know you're working on a program that involves putting aerosols, and you can be more specific about what that means, into the atmosphere as a form of geoengineering designed to um, reflect sunlight and cool the temperature of the Earth. Is that a good a good
Yes. Yep.
start? Okay. All right.
Yep.
When did you get, and what's the name of your organization that's working on that?
It's called the Healthy Planet Action Coalition.
Okay, and
And
you're the chairman of that. Is that accurate?
that's right. Yes.
Okay, and
Yes.
when did
Yeah.
you first get involved in that endeavor?
Just a couple of years ago, actually, when I discovered the existence of the organization, which was founded 5 years ago, and is a coalition of about 250 scientists, engineers, policy influencers, general public, who are very concerned that we're not headed in the right direction in terms of solving the global heating problem.
Got it. Okay. And Mark, do you have any perspective on? Well,
Yeah.
actually, no. I have to ask
Good.
Dennis another question. I'm sorry, Dennis. Can you, in 2 or 3 minutes, can you tell us how do you do that?
Well, let me start with the mission of the organization since you brought it up.
Okay.
Coalition is formed and is working to, first of all, alert the global community to the nature of the challenge we face. And second, to bring the global community together to create and implement a new comprehensive integrated climate plan, which can actually solve the problem. And what we propose is a plan that is composed of three parts: reduce, remove, and reflect. And those are the three tools that we have available to actually deal with the climate problem. And by putting them together into a comprehensive plan, we can, first of all, stop the acceleration of global heating, which is occurring now at a frightening pace, and avert many of the worst impacts that we and scientists have projected to occur, particularly among the hundreds of millions of smallholder farmers and urban poor in the tropics. And so we look to creating this plan led by a first mover coalition of most vulnerable climate countries, and putting together the plan and implementing it so that we can comprehensively avert the worst of the climate crisis.
Okay, let me ask you some questions. So you said reduce, remove, reflect, and then you also mentioned countries that are most susceptible to the climate issue. So when you say reduce, reduce what? Is that carbon dioxide? Is that what you're talking about?
Yes, reduce the concentrations of greenhouse gases in the atmosphere, which includes carbon dioxide, nitrous oxide, methane, and a number of other greenhouse gases. But the dominant one is carbon dioxide, followed secondarily by methane. So
Okay.
reduce the concentration of these gases, which we are pumping into the atmosphere every year through both agricultural practices and fossil fuel emissions. That's
Interesting, because
reduce.
when you said reduce, what I was thinking is you were talking about reducing emissions, but which is the
Yes,
amount of
yes,
new
yeah,
greenhouse gases going into the atmosphere. But it
that's right.
sounds like you're saying you want to, but then you said remove. Is the
Remove.
remove where you're removing the greenhouse gases? Oh, okay.
Exactly.
So
Yeah.
really,
Pull
when I think when you say reduce, you actually mean you want to reduce the level of
the
emissions.
emissions.
Okay,
Yes,
and then
yes.
you wanna remove greenhouse
Remove
gases
those greenhouse
so
gases
that
that
you're
are already
then
there. Yeah,
reducing the
concentration.
concentration. So the reduce is you wanna reduce the amount of new emissions. Remove is
Go
you
ahead.
wanna remove what's already in the atmosphere, and then
Bring it
reflect,
down.
I assume you're talking about reflecting sunlight.
That's correct. Yes,
Okay.
yes. Yeah.
I guess I didn't pay super close attention to your literature because I was really focused on the reflect part, right? I wanted to really hear what you had to say about the reflecting sunlight through additional aerosols in the atmosphere. But before we get into that, is the reflect part the primary thing you're working on, or is that just really just one of the three things?
The primary thing we're working on, Ned, is to develop a comprehensive plan which needs to include all three of
I
these
see. I got it. Okay.
tools, you see.
Got it.
Uh,
Because okay. I was under the impression, and obviously this was an error,
yeah.
that you felt that by doing like the reflect one of those three things, that would take some of the pressure off the other two. But you're saying all three need to happen.
All three must happen. You see,
Okay.
uh, primarily to solve the problem, we have to, first of all, stop emitting more greenhouse gases into the atmosphere. That directly increases the temperature of the planet. And then we have put so much, we put a couple of trillion tons of carbon dioxide, for example, into the atmosphere already. And we cannot bring the temperature down permanently until we actually remove a good deal of that legacy carbon dioxide that is already there. But here's the big kicker. We now know from the most recent science that we are headed for a massive increase in the global temperature before we can possibly succeed in reducing emissions or removing enough emissions. We are headed right now, as you know, we've breached the 1.5 degree threshold, which 195 countries agreed in 2015 we should never let happen. But 10 years later, we've already breached that 1.5 limit. We now are projected to reach 2 degrees by 2040. And as Mark emphasized, the damage and loss is not linear from 1.5 to 2, it is exponential. So we will expect over the next decade a massive intensification of the weather disturbances that we are already observing around the world, the droughts, the floods, the super hurricanes and super typhoons like we experience here in the Philippines, like we never did before, the massive rainfall events that are caused by increased global warming, which means there's more water vapor in the atmosphere. So when it rains, there's more rain coming down. Massive floods in Europe, in Pakistan and India this year, tremendous increase in the intensity of rainfall. So um, we have to reduce emissions to zero eventually. We have to remove lots of CO2 and methane from the atmosphere, but that's going to take many decades to do for a lot of good reasons. We are so dependent upon fossil fuels as our energy source currently, and we are dependent on an agricultural system, which is also pumping massive amounts of carbon dioxide and methane into the atmosphere. And so in immediate term, the next couple of decades, if we're going to have any chance whatsoever of stopping the acceleration of temperature and reducing the loss and damage, we'll have to do something more drastic. And that's where the reflect comes in.
Got it. Okay.
So,
All
yeah,
right,
and I
great,
can
Dennis.
explain,
That's
I can
great.
explain that. Yeah,
That's
yeah.
great.
Uh,
I want you to explain that, but not yet. Mark, Blumler, right? Am I saying your
Yeah,
name right?
hey,
Mark
there you go.
Blumler.
Yeah,
Okay.
yeah, yeah.
All right. I apologize.
Hey,
Uh,
you didn't ask him who the vulnerable countries are, but I guess we could do that later
well,
too
yeah,
if you
we'll
want.
get it. But Mark, I want to
Yeah.
give you I'm asking you to be a little bit of a devil's advocate
Oh,
here.
it's
So,
not hard for me, don't worry.
okay. So, Mark,
All
either
right,
you
so
could just go
yeah,
for it, or I
okay.
can ask you some leading questions, whatever you want
All
to
right.
do.
Let me there's so many things there. I kind of I think we're going to be talking about the reflect part in more detail later, right?
Yes.
So
Yeah. Yep.
so I won't say anything about that right now. Um the well, there's a couple. Okay, so let me just tell you a story. When I first came here, had my first class that has heavily envi majors. I asked them,
What is an NVI major?
environmental studies.
Okay.
Yeah. Yeah, I'm in geography, but, some of the courses are
I'm going to
cross.
be obnoxious and
No,
interrupt you
that's fine.
guys. And like,
That's
I
fine.
want
Yeah,
you to
I thought
speak in a
everybody knew.
language.
Yeah,
I
I thought
want you to
everybody knew what
speak in a
an envi.
language that
Yeah.
that the audience will understand what you're talking about. Okay.
Oh, man, I mean, and let me envi is through the roof. I mean, there was no envi major when I went through, but now they're very, Earth Day was before I went through really, but and that's when the movement really took off. And over the decades, there people have colleges everywhere in this country anyway have created envi programs with envi majors, and they're hugely popular, and they're very often incredibly simplistic and just sort of rah rah rah. They vary, but an awful lot of it is
Is it
anyway. So
is it environmental science, environmental policy, what?
they vary.
Mhm.
They often try to include all of that, but they vary. They're sort of they're kind of hard to fit in. They should they be housed separately? Should they be interdisciplinary in several departments? It's it's often a very awkward fit too, just because it's so interdisciplinary, right?
Okay.
Anyway, so I asked them what their climate change concerns were, and they were what they'd been hearing from, their professors who had been hearing it from the UN, the initial UN reports. And there were three, um, more and more hurricanes and stronger ones, more floods and droughts, and drought in the Great Plains. Okay, so based on what I knew about climate, I said, and other things, I said, well, the drought in the Great Plains one, that's going to go away. That's just a problem of computer power, and it'll go away. And I said, and the hurricanes one, no, they're wrong about that, because there's two contrary forces involved, essentially, in terms of hurricanes, and they're going to balance out. And I said, but yeah, they're probably right about the droughts and floods. I agree with that. Okay, I was right about two of those. I was right that the drought in the Great Plains thing would go away. And I was also correct that hurricanes were not going to get stronger or more frequent, despite what the media says. And if you look at the most recent IPC report, they acknowledge that hurricanes have not gotten more frequent or stronger.
By the way,
But
Mark, I'm just going to make sure the audience knows when you say IPCC, you're talking about it's fine, the United Nations Intergovernmental Panel on Climate Change. They put out a report about every 6 or 7 years. And in the most recent report, they're saying there's no trend in hurricane intensity from climate change.
yeah, and in terms of number too. Um, but where I was wrong was in agreeing that there would be an increase in droughts and floods, because the IPCC report also can't find that. Now, that may just be a matter of statistics, that they're looking for statistical significance and they can't get that. I'm not clear on that. But at least, scientifically, we always want statistical significance. Do we need to talk about that for your audience? Maybe, I don't know. But
Let's it's fine that you said that word. We're not going to I don't think we want to get into the definition of that.
yeah.
Well,
Anyway,
maybe if we
so the
maybe later. Okay.
scientists, and it's over 1,000 scientists that put that report together and do the analysis, and so they have not been able to conclude that droughts and floods are increasing globally. Okay. All right. So there's that. Um the the oh my god factor, yes, the temperature is warming. There's no question about that. But the other scenarios, or whatever you want to call them, that go along with it, of more storms, more, more hazardous things happening. Droughts obviously can be very hazardous. There's no actual scientific evidence that those things are happening, right?
Now,
So
one thing I would say is I try to listen to both sides on this debate, and so Dennis, I would say you are a very good example of somebody who expresses a lot of concern about the issue, and I'm hearing you say things that I hear all the time. For example, I was at a conference at the New York Times last month, and almost everybody was saying things like you're saying about increased severity of storms, um, things like that. And then I also read kind of the other side, which is saying there's too much emphasis on individual events, that if you look at the long-term trends, there actually aren't these long-term trends, or they're not as significant. And the IPCC is a good example of that. Okay,
can I give a
enough
little more?
about. Yeah,
Can I give a
please,
little more?
Mark, go for it, Mark. Yes, thank you.
Initially, initially, the IPCC was based on the models because they didn't have the data yet. And over time, as the data has come in, what they're finding is the data don't support those model predictions, although they don't necessarily completely reject them either. And I'm still holding out for that there will be more droughts and floods. It's just that so far, but I'm starting to think maybe the frontal Man, do I need to get into this? There's essentially, like where we are in the United States, an awful lot of our precip comes from fronts, mid-latitude fronts. That's gonna break down over time because, that reflects the, latitudinal gradient between the tropics and the poles, and that's lessening. Um, and what we're likely to have more of over time is more tropical air mass systems. And they should be more variable, it seems to me. That so I'm still holding out for just from my way of thinking that there will be more droughts and floods. It's just that so far it's not showing up in a way that is significant. So,
One of the things
um,
I'm hearing is there's a sense of urgency from you, Dennis, and Mark. You have I would say, a sense of wonder, curiosity,
yeah,
and
yeah.
but not a sense of urgency. So I think that's interesting. Um, Mark, anything else you want to say in response to Dennis's last um, what Dennis was talking about? And if not, I'm going to go ask Dennis another question.
Um, well, okay. I mean, I think we'll get into it later. The how are we going to produce food without fossil fuels? Man, that's good. Whoa, I mean, there's a lot yeah, I have a lot of questions, but uh, I'm not sure that we've developed those points yet. The climate system part, I'm really kind of proud of myself because 'cause I'm just an amateur and I got it right about hurricanes. Can I talk a little bit about that? About what the deal is with hurricanes?
Is that
Dennis, is that okay with you if Mark talks about hurricanes?
yes, and then I will take vigorous issue with his, claims.
Yeah. What everybody was looking at was ocean temperature because you need a certain minimum ocean temperature to get a tropical cyclone. What was being I'm not sure if it was ignored or what, but at least in terms of the way it was being taught, what was being left out is that hurricanes, well, tropical cyclones are a means of energy transfer between the tropics and the poles because it's a lot warmer in the tropics, so you have more energy there, and that's where the wind speeds ultimately those wind speeds are that they're essentially transferring energy up to higher latitudes. And so what happens with global warming is tropical oceans do warm, so you have more favorable conditions in that sense, but the poles warm up faster than the trop now that may not be happening in Antarctica actually, but it but most of our hurricanes are in the northern hemisphere because it's mostly land and or much more so land, and so that's why we get it. But anyway, so, the temperature in the Arctic can be predicted to warm up faster than the tropics. That's a basic principle with greenhouse gases. And so the temperature gradient decreases, which means the energy gradient decreases, which means that so on the one hand, you have warmer oceans, on the other hand, you have less of an energy gradient. And so I was just really just guessing that those 2 would cancel each other out. It doesn't make sense that they would exactly cancel each other out, but we definitely have not seen, in fact, there's a couple of long-term studies now going back to the 19th century for the Atlantic that show a decrease over time.
And you're talking about when you talk about the decrease over time, you're talking about the canceling out. You're talking about hurricanes, numbers and intensity of hurricanes. Okay,
Yeah,
just want to make
yeah,
sure
yeah,
that the audience is following
yeah,
us. Okay,
yeah.
all right. I know Dennis is. I suspect Dennis is waiting to jump in here. But anything else, Mark, before we go back to Dennis?
No, that's fine. I think I talked too much anyway.
No, 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 no. We all talk too much. Oh, hold on, Dennis. Before you say anything, I just want to add something about why I'm fascinated about the climate issue. Um, just I am not a climate expert. I'm just a very interested member of the audience, so to speak. And my kind of gut Don't do anything based on my gut, but I'm just going to share it. I have to share this. Um, I think that the issue of climate gets a huge amount of attention in the media, in politics, in in the advertising for the organizations that want to raise money to try to sorry about this. I think I need to upgrade my studio equipment so that doesn't happen. Okay. Um, if I get enough subscribers to this podcast, I might be able to afford to do that. Okay. Um, so you have environmental organizations that want to raise money for environmental problems, and the climate issue is an important part of that, right? And then an issue that I've been interested in. I'm now 65. An issue I've been interested in since my early 20s is the worldwide hunger issue. And I know both of you are very connected to that. Um, and I'm just concerned that the climate issue gets more oxygen. That's a bad pun, but more oxygen in the whole arena of policy. Like, what should we be focused on? I just don't want us to lose focus on what I personally think is the biggest problem in the world right now, which is severe poverty in places like sub-Saharan Africa. Okay, now that I've put in that commercial for let's also pay attention to severe poverty in sub-Saharan Africa, I will turn it over to you, Dennis.
Well, let me address your point immediately, Ned, and that is, seeing as I've been working on poverty alleviation and particularly food security all my life, um, you would wonder, why am I interested in climate change? Well, I think the fact is that the dangers of the droughts and floods and storms and typhoons, super typhoons, etc., that we're seeing are directly related to increasing food security, insecurity, and increasing the risk of having major food deficits in the future. And so it's directly tied to the hunger issue. And when you add in the environmental destruction that has already been causing major internal and some external migration of affected people, you have multiple prongs of impacts on the poorest people who are least able to afford food. And so my fundamental concern about climate change has to do with food production. I think that is the thing that unites everyone in the entire world, either lack of food physically or inability to buy enough food for the family. And of course, the poorest people are at the cliff edge on that situation. So my concern about climate change is directly related to food insecurity and the increase that we expect to see in food insecurity with global heating. Um, Now, maybe I could move on to addressing Mark's points about hurricanes, droughts, rainfall, etc. Um, I don't know what IPCC reports Mark has been reading, but the most recent report, which was published now 2 years ago, has a enormous amount of data and interpretation that these weather system disturbances are getting worse. And let's take hurricanes, for example. Now, it is absolutely true that the frequency of hurricanes and typhoons has not been measurably increasing. But the intensity of these hurricanes, that is, the frequency of higher category storms, where you get category 4 and 5 storms more frequently than in the past, where they were category 2 or 3. That is the evidence there is becoming quite strong. And that means that when you do have a hurricane in the Caribbean, Florida, it tends to be worse. Higher wind speeds, greater deluge of moisture dropped on the surface. Same thing is true here in Asia with the super typhoons in the Philippines and the other countries in Southeast Asia. So that's an important distinction. The frequency of hurricanes isn't increasing, but the evidence is becoming quite clear that the intensity of these storms is increasing. And when you go into the physics behind it, and Mark briefly looked at that, the increased ocean temperatures mean that more water vapor is getting is getting entered into the storm, and the higher temperatures increase the wind speeds of the storms. And those are the two main problems of hurricanes and super typhoons. So I would argue that that's the main concern, not that they're more frequent, but that they're more intense. Likewise with droughts. Again, it is challenging, as Mark said, to look at the statistical changes over long periods of time. And we've only been able to definitively measure that climate change has occurred within the last couple of decades. Um, but the models that show us how these systems work and why droughts occur, why more intense rainfall occurs when you have a storm, why a more intense hurricane occurs, are quite clear. The physics is quite clear that you would expect that all of these type of weather disturbances would be intensified because of the physics of how they operate. And so there's a great deal of confidence in the IPCC that these weather disturbances are going to be more worrisome in the future than they are today. And I think based on that, we can be quite confident that the impacts that we're seeing today are only a shadow of what we will be experiencing in the next decade or two with our complete inability to actually address the causes of the increased global heating. And so we can look forward down the road to much worse conditions in weather disturbances as projected by the data and the models, I believe.
All right, Dennis, thank you. Mark, I don't know if you have anything in response, because it sounds like you said the IPCC says that hurricanes aren't getting worse. Dennis is saying the IPCC says something different.
Yeah,
Before you get into that, I know that there are some other scientists that are the actual people who write those. Neither one of you are them, right? So I would say let's table this. Let's not try to solve this issue. One of the scientists is Judith Curry. She's not currently an author of the IPCC, but she is a famous hurricane specialist, and she was on one of the episodes we've had in the past. Somebody else that writes a lot about this, who I have not yet been able to invite to be a guest, is a guy named Roger Pilkey Jr. But I think it's I don't think it matters who's correct here. I'm clear that there's a lot of controversy, or at least debate, about the future. Like, what does the future hold in terms of more intense weather? And um, so let's agree to disagree, perhaps. There, yeah.
there's one aspect of this though that I can talk about that I think will be fine. There's the IPCC looks at drought. They have four different categories. They have meteorological drought, hydrological drought, ecological drought, and agricultural drought. Okay. And the first two of those, again, they find no change. So meteorologically, no change, right? Which is really what I was talking about before. Hydrologically, no change. But then ecologically and agriculturally, they do find an increase. And it's not clear to me how the first, like the meteorological one is fairly straightforward. It's based on, the weather records. Um, but when you get to the ecological or agriculture ones, that's some sort of index in each case. And, the report itself is 2,000 pages or something. And then this is in appendices. And so I just haven't had time. I mean, I'd really love to take the time if I had it to go try and find out how those indices are calculated. But I don't know. Right. So anyway, so even there, you've got some incredible complexity involved to the report and to all of that. So, and yeah, you're right.
Let me change the subject slightly. Dennis, I really want to hear the a bit of detail about the reflect part of your 3-point program. And one of the earlier episodes of Climate Verso, we had an advocate for the idea of removing carbon dioxide through ocean fertilization. So that's a whole separate episode. It was actually episode 1 of Climate Verso. And we got into a lot of the detail, and the devil's advocate I had on for that one was, talking about oh, and by the way, the advocate was Peter Fikowski, who both of you know quite well, right? So, but the devil's advocate was saying, well, Peter, I'm concerned about the potential unanticipated consequences. That was a very interesting conversation. And by the end of the conversation, the devil's advocate was a little bit more relaxed. I thought that was very interesting, a little bit less concerned. Dennis, I'd like you to talk about, what, just describe for the audience first of all, what's it called when you pump aerosols into the atmosphere to reflect sunlight? What is that process called?
It's called stratospheric aerosol injection.
Got it. And my understanding is that's intended to mimic what a supervolcano would do.
Yes. Yes, exactly.
And we actually
Exactly.
know
Yeah,
what happens when a supervolcano explodes because it has happened many times, including Pinatubo in 1991?
that's right. I
Was
live
that
nearly in the shadow of Mount Pinatubo. It's about 60 miles from here.
Mm.
wow. Okay.
Yeah,
All
yeah.
right.
I was
Right.
I was there when it erupted in 1991,
And you're
and
still here. That's impressive. Okay.
yeah, but
I mean, you didn't get buried in lava.
I got pretty close to being in serious
Wow.
problems. Yeah, but
Wow. Okay.
the point is that when Mount Pinatubo erupted, and it was the biggest volcanic eruption in the 20th century. Um, the U.S. Geological Survey and the Philippine Volcanology Institute here were able to monitor the effects both locally and globally over the succeeding years. And what they found, Ned, was that the volcano ejected about 20 million tons of sulfur dioxide and a number of other things into the stratosphere, which is the outer layer of the Earth's atmosphere. Goes up 15, 20 miles. And when the volcano did that, these aerosol sulfur particles spread all around the planet. They gradually spread all around the planet, forming a uniform net that reduced the incoming solar radiation by something like 0.5% or so over the next couple of years. And the temperature of the entire planet declined by 0.5 degree. Now, that's pretty amazing when you consider that at that time, the entire increase in global temperature from pre-industrial times, before we were, using a lot of fossil fuels, was about zero point 0.7 degrees. So, half a
And you're
degree meant that
talking you're talking degrees Celsius, is that right?
Yeah.
Okay. Mhm.
And so most of what human civilization and emissions had accomplished in increasing the global temperature over the past couple of centuries was actually uh, wiped out for a couple of years by
Hmm.
the sulfur dioxide that was forming this veil around the planet. And they said, wow, if this could be done, I mean, we know what all the effects were because they were monitoring effects of the volcanic eruption up, down, and sideways for years after the volcano. And interestingly enough, there were very little negative effects on agriculture and other aspects of industry, people's livelihoods, health, etc. And so they said, well, if that's possible, why couldn't we simulate what the volcano did and control it very carefully so we can ramp it up or down exactly as we want to do by injecting these same type of aerosols into the upper atmosphere and using like a fleet of airplanes to spray the aerosols in a very controlled way. And subsequently, there have been thousands of scientific papers and engineering studies of how you could do this in an optimal way. And if I could summarize, what scientists and engineers are telling us about how this would work, you can, for a few $1 billion a year, develop a system which has a whole number of dials that you can twitch to optimize the way in which you do this. And you can, in fact, establish a goal of what temperature you would like to aim for, and thereby control the way in which you would spray these aerosols to actually do that. And why is this important? Well, as I mentioned, we are completely failing to reduce our level of emissions. Emissions continue to go up every year, and the concentration of carbon dioxide in the atmosphere jumped to an enormously higher level last year than any previous year. So we're not reducing our carbon
Wait,
dioxide in
Dennis,
the
can I
atmosphere;
just?
it's
I just want to
increasing.
interrupt you. Yeah,
Yeah,
clearly,
yeah.
carbon dioxide is going up, but you're saying the rate of increase is went up a little bit more last year than previous years. I hadn't noticed that.
Yeah, yeah. I mean, fossil fuel emissions continue to rise at a fairly steady
Correct.
rate. But
Right.
last year, the CO2 concentration in the atmosphere took a big dramatic increase. And why?
But
Not
hold on.
simply
Do you
because of
how
carbon
much was that
dioxide.
dramatic increase? How much was that? I just have you're the first. I have not heard that yet. So if you want to say
Oh,
that, that's
okay.
great. But I want
Yeah,
to hear
yeah.
some data. Yeah.
The World Meteorological Organization just published the data for last year, and normally the carbon dioxide concentration increases somewhere between 1.7 and 2.4 parts per million per year. Okay,
Got it. Yep.
last year it jumped by about 3.5 parts per million
Well,
in 1 year. I
got
mean,
it. Okay.
no
Okay.
previous year was
Understood.
anywhere
Understood.
near that level, you see,
Got it.
which has an alarming implication, Ned, which is that we're decoupling from human emissions. Human emissions didn't go up by 50% last year. They only went up a
Right.
few percent,
Right.
but
Okay,
suggests
but
that
hold
the
on a
Earth
sec.
is.
Got it. I got it. I got it. Because I was going to say my understanding is human emissions are something like 3% of all, or no, there's this carbon cycle, right? So carbon dioxide's constantly going into the atmosphere, back into the oceans. It's being absorbed by plant life.
Yeah,
And I'm sure there's a lot more, right? I'm not getting to everything, but that the actual amount of carbon dioxide that humans produce is only about 3% of that carbon cycle. And it sounds like what you're saying is that something else is going on such that the
yeah,
carbon cycle was not absorbing as much as it had been. So therefore the atmospheric level of CO2 grew by 3 or 3.5 parts per
yeah,
million, whereas
yeah,
normally it would be more like 2
yeah.
parts per million. Got it.
That's right. Yes,
Okay.
yes,
Got
that's right.
understood. I understand what you're saying.
Yeah,
Thank you.
yeah,
Okay.
yeah, yeah.
But keep going. I
So,
interrupted you, but keep
so,
going there.
so, so in the midst of all of this and the concern about this fairly recent but dramatic increase in the rate at which global heating is occurring. And of course, it will jump up due to this increase in carbon dioxide in the atmosphere because the temperature of the planet is directly correlated with the concentration of CO2 in the atmosphere.
Dennis,
So,
hold on. Mark, do you agree with that statement? I want to find out because
Well,
this is perhaps the crux of the issue. Is look, I apologize. I'm supposed to be neutral, and I try to be neutral, but I've been trying to be convinced for 25 years. I've been trying to be convinced that what you're saying is accurate, Dennis. That the amount of carbon dioxide is the thing. And I'm willing to be convinced, but I haven't been convinced. So I appreciate
all
what
right.
you're
Yeah,
saying, but I
I
know
think,
there are
I,
other views. Mark, do
yeah,
you have
well,
anything you want to
okay. I
say about
mean,
that?
I I always come from, well, maybe pretty much everything. But the thing about this, if you go back to the glacial interglacial cycles, okay, you know what I'm talking about? That we've the last couple million years we've had at least 16 glacial periods, alternating with interglacial periods when the climate is more or less like the last 10,000 years. Okay,
For our audience, a glacial period is an ice age, and interglacial is now when we're not, other
yeah,
than
sure.
the Arctic Ocean and Antarctica, there's no ice, there's no permanent ice. So we're luckily in an interglacial. I only get to go skiing in the winter. Okay.
Right. Okay, so the CO2 and actually methane also track pretty well the temperature changes. So you'll have, basically you have a sawtooth where the temperature gets colder in sort of an up and down pattern. So what we call a glacial period is actually it gets gradually colder, but with a lot of ups and downs, okay? And then tends to rather suddenly leave that state and go to an interglacial state, all right? And if you look at a graph of CO2, it tracks that pretty well, and methane a little less well, but pretty well. All right. Now, the question is, does the CO2 and methane, do they increase before the temperature change, just after the temperature change, or, synchronously with it? It's really, really hard to get at that because you have to have really fine-toothed, really detailed, data. They do have some really good data, but it's still really, really anyway, my read on that, and I'm not completely up to date on this. I'm probably 10 years out of date at this point, maybe even. But my read on that is that there's no real good evidence that the greenhouse gases precede the temperature change. If anything, they come after.
Okay.
That's yeah.
Nevertheless, there are
Wait, do you
there are,
understand what I'm saying? And what I'm saying is,
Mhm.
in the past, it looks like they're related, but not that they're necessarily causal. All right. Now, when you come forward to today, to the last few hundred years, I mean, that's just, we don't know. We know that both things have been happening, but we don't really, there's good, reason to think that increased CO2 would increase temperature. There's absolutely good reason to think that. But given that we don't really see that in the paleo record necessarily, I
okay,
think it's an
Mark.
open
Nevertheless, Dennis, I fully understand why you're saying what you're saying because it's what everybody says, right? It's what the majority of the
No, no, it's what
professional
the science says, Ned. It's not what people say.
No,
I
I'm
don't
talking about
really.
the science. I'm
It's what
talking
the
about
science is
science.
saying. Yeah,
Yeah, no,
yeah,
it's what the
yeah.
majority of the scientists say. There are scientists who will challenge that, and but that's fine. I'm giving you that. I'm giving
Mhm.
you that carbon dioxide is an important part of what impacts temperature. Okay,
Yeah,
even though I
yeah.
know there are scientists who might disagree, but
Hmm.
let's assume that that's a given. Okay, at least for the I've at least raised the question about that. But let's assume that's a given. I look, you have a good shot of convincing me that stratospheric um how do you what say it again,
Uh,
the injection.
Stratospheric
Right.
aerosol
It sounds
injection.
to me like stratospheric aerosol injection might be a much more cost-effective. In other words, if it's
Yeah,
really, it's first of all,
yeah,
to me, it
yeah.
sounds like that might the control knob, so to speak, of temperature,
Yes, yes,
that might be
yeah,
a much better control knob than carbon dioxide. In other words, let's say I'm a skeptic about that carbon dioxide is such a
okay,
fine-tuned control knob, but the aerosols, that makes a lot of sense because we have such direct evidence from things like Pinatubo.
right, right.
Right.
Well,
Also, it's now you mentioned it would be a couple $1 billion a year. That seemed to do these
yeah,
to do this geoengineering. That seems much less expensive than trying to change the entire Earth's energy system.
yeah, yeah. Okay.
All right, Dennis,
Um,
you have the microphone.
okay, great, great. Let me first resolve the issue that Mark brought up from the paleoclimate data. The reason that science is so crystal clear that increased carbon dioxide in the atmosphere is warming the planet is the physics of carbon dioxide interacting with infrared radiation. The physics is absolutely clear that more carbon dioxide means more of a blanket that traps infrared radiation and therefore holds heat into the planet and is the reason why the overall planetary temperature is increasing. Um, that physics is so clear and so definitive that I don't know of any
We
challenge to
No,
that.
no, no. We're neither Mark nor I is challenging that at all, Dennis. That's not what we're
Well, no,
challenging.
to
No,
intent.
no, that's not what I was saying. What I was
Oh,
saying is that, um, it has more to do with the magnitude of the effect and whether there's time lags, and things like that. Or whether there's other
well, then we
players.
agree. Then we agree. I mean, it's very definitive, and that's why there is such a consensus scientifically that if you put more CO2 into the atmosphere, you will increase the temperature of the planet. So that's that's pretty
Actually,
uncontested.
that's no, okay. So again, you're re what you're putting out there is I think the consensus, if you wanna put it that way, but there certainly are multiple, uh, alternative scientific speculations, you could say, I guess. You could go back to Arrhenius, who was the first scientist to suggest that CO2 was warming the planet, and he did some calculations, and they were based on, again, a curvilinear, not a linear relationship, so that the warming would be greater initially, and then as time went by, it would start to move towards an asymptote, right? And there are people still today, scientists suggesting that happens. So, I mean, and then there's others who suggest that water vapor is more important and so on. So there's actually multiple views out there, which is to be expected in science, I think. Um, my own take on this from day one has been that you look at the geographical pattern with CO2, with greenhouse emissions, you expect more warming at night, you expect more warming at high latitudes, and you expect more warming in winter, and that's exactly what has happened. So I do personally think CO2 and methane and the others are playing a role. Now, that doesn't mean though that they're the only players or that their influence will continue to be equivalent to what it was. There's some really interesting scientific questions, man, I mean, there's just so many interesting scientific questions around climate change, and a lot of that is kind of getting pushed aside in the sort of oh my god sort of environment that we're in right now. But yeah, I don't personally. I've always said that yeah, greenhouse gases are warming the climate. It sure looks that way. Yeah,
Yeah. Okay. Well,
yeah.
maybe I can go back to Mark's uh, further question, which was on the development of this sunlight reflection method and other methods that could assist us as we approach a solution for the climate situation. Now, the first thing we need to recognize is that sunlight reflection methods do not fundamentally solve the problem. In order to fundamentally restore a safe climate, you must stop emitting carbon dioxide, methane, and other greenhouse gases into the atmosphere, which warms the planet, and you must remove a good deal of what we have already there in order to be able to bring the temperature back down to a safer level. And we've already reached a level that is unsafe. 1.5 is generally acknowledged as unsafe, as embodied in the Paris Agreement of 195 countries who declared that this was our our aspiration to keep the temperature below 1.5, but it has exceeded 1.5 and it will continue to go up. So we recognize that we must eventually do both of these. We must reduce and remove. But the problem is, and perhaps the delusion is, that we could do that in a short period of time by 2050 or even 2070. It's very unlikely that we will do that in such a period of time. And Mark alluded to this because fossil fuels are the basis of our energy system, which is the basis of our prosperity and our livelihoods. And so it's going to take decades and decades for us to gradually electrify our economies through renewable energies like solar, wind, batteries, and other geothermal, hydro, etc., which are now, by the way, expanding at an exponential rate. So we now can confidently project that eventually we will be able to power our economies by renewable energy quite comfortably, and increase our energy amount for humanity by leaps and bounds, which it needs to do in order to electrify Africa and Asia, etc. But that will take so many decades, and what we know now is that we're out of time. If our temperature is going to surpass 2 degrees by 2040, and we have a vast literature in the IPCC reports and elsewhere that the impacts of that are potentially disastrous. If not for the comfortable people living in the North, for the people, the billions living in the South. And that's my great concern. I mean, people living in the North can afford to be skeptical about climate change because they are both prosperous and they can find ways of adapting. Um, a New Yorker can buy a better air conditioner with greater capacity as the heat load increases. A, a rural farmer in India could never afford air conditioning and has to bear the brunt of excessive heat, which last year, by the way, in Delhi, reached 52.5 degrees centigrade. Now, what is that Fahrenheit? Is that somewhere around 120 degrees centigrade, Fahrenheit? Um, no air
Yes,
conditioning
it is.
available.
It's around
No air
120
conditioning.
degrees Fahrenheit. Yes.
Yeah, no air conditioning available for billions of people in the tropics who could not aspire to own one. And while we worry about, well, is climate change going to be very effective? Is it going to really have those disastrous effects? In the North, there are ways of adapting. We have the funds, the money, the ability to do that. But if we look at the South, where they're already suffering from excessive heat and floods and droughts, etc., are more intense, then the concern we ought to have for our fellow humans is that the problem that we're creating in the North by our fossil fuel emissions, not theirs, they have a very small fossil fuel emissions compared to the countries of the North, including China. Uh, that means that we are responsible for a problem that they will bear the brunt. And um, and when you talk about the justice of that situation, I think we ought to be more concerned about the lives and livelihoods and the risks that they will bear in the future. And, if we comfortably say, well, climate may get worse, we may have more of these problems. We don't know. It's not statistically significant yet. We're not sure about the science. Well, when it actually does happen, we could say, "Oh, well, we were wrong about that." But the the impacts, are going to be felt. And, you know, gentlemen, I'm sure you have house insurance. I'm sure you buy, insurance for your home every year. The chances of your home burning down are less than 1 in 10,000. But for some reason, you buy house insurance. That's interesting. Well, is the chance of global warming causing greater impacts to people, particularly in the South, greater than 1 in 10,000? Absolutely. The International Association of Actuaries, these are the professionals that monitor risk for companies, governments, etc., all over the world. They got together and issued a report earlier this year in which they sounded the alarm loud and clear that the risks of global warming were so high that it was impossible not to bring them into all risk analyses for the future. And they actually projected that there is a significant likelihood that if we pass 2 degrees, 2 billion people could die. Look at the report. That's the conservative group of financial analysts who are actuaries, the guys who run insurance actuaries.
Sure.
They're raising the alarm like nobody else has, that we are facing a very, very serious risk of civilizational destruction and collapse, not just greater impacts, but the whole civilization of humanity could actually unravel if we don't pay attention now to what we need to do.
Okay, Dennis,
So Ned,
let me just
yeah,
interrupt for a sec. And first of all,
yeah,
I'm going to look up that report and read it. Thank you.
yep,
Look, I'm if I sounded like I was arguing against you, I apologize for that because that's not really my intention. Okay, it's really my intention to have an interesting conversation between people with different points of view.
yeah,
And I
yeah.
apologize. I have a
Oh
point of
no,
view. I really
no,
apologize. I sometimes it slips out. I really want to be an intermediary, and I think I goofed there. Okay,
I think you
never.
goofed because you haven't no offense, but I think you haven't given me much time.
Okay, well, Mark, this is a
I really
conversation.
wanna go back,
Okay,
way back to the reflectance and then come
okay,
forward.
yeah,
yeah,
There's a number of okay, I don't see any harm in studying that and possibly doing it, but there are some things that need to be considered at least, and maybe you are, but you didn't, and one of them, of course, is that, you get destruction of ozone, right?
that's right.
And I doubt that that's
Mm-hmm.
just because of the way science works, I doubt that that's really completely understood. In other words, there'll be some guesses, some hypotheses about what causes it and at what rate,
Hmm.
but it's the kind of thing that until we're playing around with it, there's gonna be surprises. There's always surprises, and we do not want a downside surprise on that one because that one that one could potentially kill almost everybody. I mean, if
Mark,
you
say
really
just
destroy
say more. What's the concern about ozone? I just want to make sure the audience understands what you're
well,
talking
the
about.
reason there was movement on ozone back in the day, well, there were 2 reasons. One was that economically it wasn't a big deal the way in comparison with, say, phasing out fossil fuels. But the other is that if you destroy the ozone layer, it's possible that there would be no life on land. We don't actually know if that's true or not, but life doesn't come out onto land until the ozone layer is created.
You're saying
And so the
in the geological record, the paleontological record, all life was in the oceans. No life could not survive on land because there was no ozone.
well, there may have been some stromatolites or something, but essentially, yes, there was no movement out onto land until you had an ozone layer. And
And
there's
this was a
uh,
couple 100 million years ago.
it was more than that,
Okay.
yes.
Mhm.
And So what people talk about is melanoma, and that's yes, there's definitely an issue with melanoma for humans, but you also have an increased mutation rate. And it's not out of the question that if the mutation rate is great enough that you're just like, "Oh, well, you can't function," right? Nobody knows, but it's an interesting, coinkydink that you do get the ozone layer, and then you get this incredible diversification of life on land, so much so that actually life is more diverse on land than it is in the ocean, whereas that certainly didn't,
So
start out that way.
so what
So,
is the risk of sulfur dioxide injection into the atmosphere? How does that hurt ozone?
I don't know I mean, the chemical water vapor gets involved too. The chemistry of it is complicated. This recent eruption, Hunga Tonga, which was an undersea eruption. It threw up aerosols, but it also threw up a huge amount of water vapor up into the stratosphere, and it's destroying ozone. I mean, that happened 2022, and it's still destroying ozone as we speak. I'm not sure what the rate is, but the phrase that's being used is it hydrated the stratosphere, and the stratosphere is still hydrated. And I suspect that's because aerosols come down fairly quickly because but water vapor probably doesn't. It probably takes a lot longer just because of the nature of the molecule to settle out of the higher levels of the atmosphere. That's just a guess on my part, but so because apparently they didn't really expect that. What they were able to get in there with Hunga Tonga right away, just like in fact, even faster than Pinatubo, and really start taking measurements. And among them, they found that yes, ozone is being destroyed, but the chemistry, it's not simply a matter of the sulfur dioxide. There's the chlorides from the ocean play a role, right? You got chlorides in the ocean. And if you think back, it was CFCs, chlorofluorocarbons, right?
That was the those were the ozone, uh, those are the chemicals that were harming the ozone layer.
Yeah.
Yep.
Yeah. Yeah, so in that case, so that's different, I'm sure, from what Dennis is proposing. He's not proposing to send up chlorine at the same time that he that he sends up aerosols.
Okay.
That would not be a good idea, not at
Dennis,
all.
Dennis,
Well,
I saw it looked like you were shaking your head in agreement when Mark brought up the concern about ozone. It looked like I
Yes.
it looked like you were agreeing. So, let's do
Uh,
you have anything you wanna say, in response?
Absolutely. I've got a lot to say. Ozone is a potential risk for stratospheric aerosol injection and has been recognized as such for a long time. And so there's now a body of literature that um, uh, has studied what would be the level of ozone depletion that one would expect with given levels of stratospheric aerosol injection. And that literature could be summarized, perhaps a little oversimplification, but my colleagues who have worked on this indicate that it's not really going to be a problem. There will be some depletion of the rate at which the ozone layer is is healing, because every year the ozone layer is getting a little closer to its previous level before we started putting these refrigeration chemicals into into the ecology. Um, but when we stopped basically doing that, the ozone layer has been gradually healing itself year after year after year, and is projected to be fully back to, let's say, pre 1980 levels about 2050. But if we do practice stratospheric aerosol injection, the rate of that healing process will be deflated, and so it will take longer to reach that point. The bottom line is that ozone is not a killer factor for using SAI, but it is one of the risks that must be carefully monitored and understood, and and that it is one of those things that you may have to bear with the risk of that ozone depletion rate if you are applying the technology and benefiting from all of the upside of using the technology to reduce the rate of global heating, or stop the rate of global heating, or actually begin to reverse that temperature back down to a safer level, which we project as around 1 degree or less Celsius. So it's one of those risks that you want to carefully study. And the thing about doing these practices, there's a long list of potential risks. There's a long list of potential benefits, and one takes a risk analysis in order to be able to determine whether to use the technology, how to use it, how much of it should be used, how intense it would be applied. And so there would be a very slow ramp up and optimizing of the application of any solar radiation management method, in which you could ramp it back down again if you found that there were risks that were far beyond what could be expected. But as I mentioned, in the case of stratospheric aerosol injection, we had a massive injection of sulfur dioxide into the atmosphere in the 1990s, and the temperature of the planet was effectively reduced dramatically. And 0.5 degrees Celsius is huge. That would be wondrous for our climate if we were to be able to do that again artificially. But the risks that were monitored were very were very insignificant, and so we do have a massive natural experiment that has already occurred that we are trying to mimic in the process of doing research on stratospheric aerosol injection.
Dennis, I have a question, and something I read about another large volcanic eruption in the late 1800s. Uh, was it
Krakatoa.
Krakatoa? Was that in the
Krakatoa.
and
I live close to that one also.
okay, because look, what I
But I
read is that
Indonesia.
led to
Yeah,
right. That's in Indonesia,
yeah,
and Hunga
yeah.
Tonga, the one that was in 22. That's also Indonesia, right?
Yeah.
Um,
It's more in the Pacific, whereas
Pacific,
Krakatoa's more on
Pacific.
the
Yeah,
Indian Ocean
All
side.
right.
yeah,
So I
yeah.
I don't claim to be an expert on this, but one thing I read, so it's just something I read, was that the global temperature fell substantially for a couple of years, and that it led to really severe agricultural disruption and some severe famines.
Yeah, yes, that's right. Yeah, yeah.
Any
Uh-huh.
comment? Any? I mean, any?
Absolutely. Well well, that was a catastrophic, volcanic eruption, uncontrolled, of course. I mean, humans had nothing to do with it. And of course, one would never, ever countenance the idea of blasting the amounts of sulfur dioxide into the atmosphere that Krakatoa did. I mean,
Mhm.
that would be pretty stupid, wouldn't it? we know that though you can overdo it. But why overdo it? I mean, it's more costly. It's costly to put aerosols in the atmosphere. You would want to put the absolute minimum, and we're talking about very small amounts. Ned, currently, humans eject 50 million tons of sulfur dioxide into the atmosphere. Coal-fired power plants, vehicles, diesel, gas engine, all kinds of things eject sulfur dioxide into the atmosphere, and the health problems that it occurs. Millions of people die as a result of respiratory problems caused by these emissions. Well, how much would we put into the atmosphere with stratospheric aerosol injection? Maybe 1 million tons, maybe 2 million. That's a tiny, tiny fraction of what we're already putting into the atmosphere. And so people say, why are you messing with the planet? Why are you thinking of doing something like this? And we say, look, folks, we are messing with the planet to an enormous degree right now, and nobody seems to care. And then scientists come along and say, we could help improve the livelihoods and the risk avoidance of billions of people by doing a little bit of stratospheric aerosol injection. And then suddenly there's a big hullabaloo that it's too dangerous to do this sort of thing. But we're
Dennis,
already doing it.
you're doing a
We're
very
already
good
doing it.
job. You're
All
do
right, so I guess
you're doing
another
a very good
question
job
is,
of convincing me. But Mark, go ahead.
yeah, no, it does sound like if you're gonna do it slowly and
Very
gradually,
slowly.
that
Yeah.
you probably would be able to get a handle
Mm,
on
mm.
the ozone, which I think is the only one that's really a major.
Yeah. Yeah.
The others, there's gonna be other things. You're gonna have differential climate effects because, unless you're putting more aerosols up in one part of the globe than another, you're gonna have, it's a different overall effect from the greenhouse effect, right? So there's gonna be some climate effects there that are gonna have differential impacts.
Mhm,
Do they
mhm.
matter? I don't know. That's an interesting question.
Yeah. Yeah. There
Uh,
will.
um, but I suppose you could even look at that. I don't know if you're
Yeah.
thinking about
Yeah.
that, about looking at, for instance, precipitation impacts in how they might play out in different parts of the globe, and then whether you could adjust where you put the aerosols, for instance, would that.
Exactly, exactly. Oh, last week we had a major global online conference where we got together the top experts in a whole lot of areas related to climate impacts and solutions. And Doug McMartin summarized the studies that have been going on to understand what are the differential or regional climate impacts of using stratospheric aerosol injection. He's a professor at Cornell University that has done work over the last couple of decades on this, and there's a huge number of researchers working on this all around the world, about 45 countries now. But Doug showed us that if you optimize the way in which you apply the sulfur dioxide, where you inject it, how you inject it, when you inject it during the annual cycle, etc. And you twist these dials and you optimize it. The effects on global temperatures and precipitation can be, in fact, um, evened out, so that the overall effects of stopping and reducing temperature through this method can be very similar to the effects that would occur that were present as our ambient baseline back in the 1980s, for example. So there's some very good work going on in this area. Yeah.
I'm sure there is. I'm sure there's lots of really creative and thoughtful stuff, and at the same time, I'm sure it's not gonna 100% turn out to be true, but if you do it gradually,
Yeah. Yeah.
you can adjust. So I don't really have major concerns about that. Um,
Dennis, when you and I first met, you mentioned that you were lobbying governments in the third world to do this.
Yes. Yes.
Can you say
That's
more
correct.
about that?
Yeah. Yes, indeed. Not only we, but also the head of the Overshoot Commission, which is a very senior body of former presidents, prime ministers, etc., um, led by Monsieur Pascal Lamy, who was former head of the World Trade Organization. Um, uh, Both he, his organization, and we, the Healthy Planet Action Coalition, have been working together on what we call a high-level diplomatic effort to approach and discuss with the heads of state or their senior advisors the possibility that the most climate vulnerable countries would come together as a first mover coalition. Let's say Brazil, India, Philippines, Kenya, Ghana, etc. Very, very vulnerable countries that have a lot of political problems because of these floods and droughts, etc., excessive heat. And if we could identify several of these countries to take a leading role to champion a new comprehensive integrated climate plan, then they could call together the best expertise from around the world to develop all aspects of the plan, reduce, remove, reflect, and put that together into a combined effort, which would go way beyond what is happening at the current climate change convention, which is focused really solely on emissions reduction at this point, unfortunately. And it would be this first mover coalition that could galvanize the global community. And they say to them, look, it's happening in our countries. Look at the evidence in Brazil and India, etc. And we are facing political stress because our people are asking us, what are we going to do? So if they champion this approach, we can develop this comprehensive plan, and of course, it could seep into the Convention of the Parties for the UN Climate Convention as well, eventually. But those things take time. But the great way to start a program like this is with the most vulnerable countries as the champions of this new approach.
Where does that so but it still sounds like it's something that might happen down the road. It doesn't sound like it's something that's happening in the next year or 2.
Well, we're engaging in those conversations currently. President of the COP, the Prime Minister of India, etc. But the discussions have not reached the point where there has been a declaration yet. We hope that perhaps by next year we might reach that goal. But international diplomacy is a quiet and a very complex aspiration. So we have to be realistic as well as very vigorous in working on this. But I am confident that that's where the initial impetus will come from. Countries that are facing these disasters or have actually experienced these disasters coming together and saying, "Well, we just can't sit by and let this process just carry on indefinitely, and go nowhere. We've got to take action."
So
Mark,
Dennis,
go ahead, Mark.
a couple of questions. I mean, it sounds like, with the reflection, you're planning, the idea is to just do it until the others are until right?
Yes.
Because otherwise it's $2 billion forever, right? But
Right.
so, okay, so now let's go back to that, to the, reduce, remove. Is there a particular CO2 level that you're ultimately aiming for, or
Mm, Good question. Yes. Well, take for example Dr. James Hansen, who has been generally recognized as the foremost climate scientist in the United States for the past 40 years. He was asked this question, and he's answered it many times. And he thinks that probably about 350 parts per million is an acceptable carbon dioxide concentration in the atmosphere that could bring us back to a safe climate. Now, our current concentration is 424 parts per million. So we've got a ways to draw down the current level of CO2, and if we don't draw it down, it will stay there for hundreds of years. So 350 is one. Now Peter Fikowski, who was interviewed by Ned recently, he is more ambitious, and his thinking is that we should bring it back down to the pre-industrial level
Yeah,
of less than
yeah, I know.
300 parts per million. Um, which I mean, if we could get it back to 350, then we could decide whether to go further or not. That would be such a tremendous boost if we were to be able to do that in the first place. So the decision on what's the optimum level of CO2 concentration is going to be a sliding scale as we go forward.
Okay, good. Yeah, no, the reason I bring that up is that I think there's a real danger if we bring it all the way back.
Right, right.
Little ice age was not a great climate for humanity.
True.
350 might work, but I think it's also just hard to know, we'd have to be just paying attention, right? Because yeah, 350 sounds reasonable to me,
Yeah.
but we don't really know. We don't really know what triggers the next ice age, for instance. We wanna make sure we don't go there.
Yeah.
Yeah.
Well, we sure, and we
You
could do
just
that
have a
very
CO2
successfully.
around to pump it as soon as you see it's gonna happen. Okay. Alright.
Yeah,
I didn't
yeah.
know we had a CO2 reserve that somewhere, but that would be,
Well,
that
it's
would be
called
a
fossil
thought,
fuels, and there's
actually.
a
Wait, when
Yeah.
I was growing up, when I was a teenager, I was told we were running out of oil. What happened?
we were at them
Okay.
unknown methods of extracting oil from the ground, and that changed the whole situation. But
Well, I don't know. I think that's actually fracking is starting to, well, in the US, fracking is starting to get a little long in the tooth. There's plenty of other countries that have never fracked and that still could,
yeah,
but that's not a quick fix. If you need CO2 suddenly, fracking's not gonna do it. It's not like gusher oil where you just put something in the ground and boom,
yeah. No,
oil comes
no.
out.
Ned was
Yeah,
simply
peak oil.
answering the question.
I see, yes, okay.
That
But
we
I
we
thought
didn't run out of oil because we invented new methods of extracting oil, which were abundantly successful.
yeah, although they do.
I think we're getting close to wrapping this up. I want to give each of us a chance to just see, are there any loose ends? I know
Mm.
one question I'm still left with, Dennis, is you mentioned the proportion of sulfur dioxide to inject into the atmosphere relative to sulfur dioxide pollution that's already happening from
Every
and
year. Yeah,
yeah, and
yeah.
so is it that the sulfur dioxide pollution doesn't go that far up? It doesn't go high enough into the atmosphere to have this reflective
Effect.
effect?
Good question. In fact, it does have a reflective effect. And James Hansen has shown us very elegantly that the amount of pollution that we're talking about here, that 50 million tons I mentioned, has actually been masking global warming to an extent of about a half a degree. But we are becoming more successful in reducing pollution. And that success has been drawing down the amounts of, it used to be 100 million tons, Ned, some years ago. Now it's down to 50 million. And as it goes down further and further, the masking effect of these aerosols disappears and the temperature lurches up. It's one of the reasons why we have this dramatic acceleration of temperatures in the past 10 years or so, is that pollution control has become so much more successful in China and international shipping that there has been a major reduction in the amount of aerosols polluting the atmosphere. So that very process, and in fact, I mean, you could make the claim that we ought to pollute more to reflect more sunlight, but that, of course, is not very logical because of the health implications. It's very unhealthy to experience that level of pollution. Whereas if you put a million or two tons of sulfur dioxide way up into the stratosphere, it stays up there for quite a while, 1 to 2 years, and then it gradually filters down predominantly into the oceans and has very, very little effect on humanity. But 50 million tons a year is having very direct effects on humanity right now.
Oh, absolutely, absolutely, right. Um, okay, Mark, do you have anything else you would like to add?
No, I think the whole it's gonna be interesting trying to get the nations on board. I think, you may find that you need to do it without them, um but, um, it's a great I mean,
Mm.
it's like what Peter's doing. It's definitely um, I mean, I like it and I don't because I always worry about unanticipated consequences, but I certainly like the the approach. It looks like you're attempting to put in, um, measures and sort of, checks and balances to ensure that it doesn't go off the rails.
That's right.
And, yeah,
Yeah.
and so
Yeah.
that's great,
Yeah.
I'm happy about that. And I think 350 actually sounds reasonable. I don't think we really know yet
Yeah.
what the
Yeah.
optimum
Yeah. But
level is for
yeah.
us or
But
for the
we
planet. I don't
we
know
would
that yet.
monitor
Mm.
constantly, all aspects of application of any of these technologies and their implications, their effects, on all different indicators. And so what we in the Healthy Planet Action Coalition, our scientific group, is really proposing is that we bring the global community together, we develop this plan based on the best science and engineering that we have. We do a huge amount more research. I mean, although we have thousands of papers on the topic, the amount that's spent on research on this is just a drop in the bucket. Although the National Academy of Sciences has called for a major program of research in this area, as well as the UK and other countries, but we need to ramp up the research and consider this like a moonshot. We don't know exactly how to get to the moon in 1960, but we knew that we had enough science and engineering to take a shot at it and to develop the technology that could take us to the moon in another decade. And that's what we need to do right now with our reduce, remove, and reflect paradigm, is to really ramp up and accelerate the research that we're doing on this so we can answer these questions about ozone and other potential risks, and we can estimate very clearly what the effects will be as we do more field trials, small field trials, to understand the physics, understand the atmospheric chemistry, understand how these things will work out when you start applying them at small amounts, so that we can gradually ramp up and come to a level, an optimum level that could, as you say, Ned, protect us from the worst of climate change while we solve the emissions and removal challenges. So you
I
see,
think
it's not it's
there's
not
one other issue
separate.
that
They're all together. Yeah,
sorry.
yeah,
There's one other issue I think in terms of the poor countries. You look at Indonesia, let alone China, India too, as far as that goes, that if they want to have a standard of living that approaches ours, the fast way to do that is fossil fuels. There's just no question
uh-huh,
about that. And so a lot of those nations are going to want to be, and so far, Europe, especially, and us, we've been really kind of attempting to prevent that. And to some extent with some success, but boy, I just think it's gonna be a hard sell to say, "Oh, no, you just do renewables and we'll take care of the temperature with the sulfur dioxide." And you can see it here. I mean, that's why Trump is going big time into, he's even gonna open up coal again,
yeah.
because it is still more economical to do fossil fuels. I mean, that's just the facts on the ground right now. And so pocketbook is gonna come into play here big time,
Yeah.
and
Th
I
this is
think
why
if you
they
really wanna do it, you're gonna have to do it probably with, just do it,
yeah,
without necessarily having these other nations on board, I
Dennis,
would think.
Dennis, is there a possibility that Brazil and Kenya, I'm just picking two that you mentioned before, would just decide to do this on their own?
Um, well, of course, it is possible that any country might decide to do it on its own. But I think the history of global diplomacy is that any of these countries would see the dangers of doing it on their own. They would run into such diplomatic flack. And the community of nations is together because there are an enormous number of interactions between them. And if one nation goes out and does something, there are many, many buttons that other nations can put to make things difficult for a nation doing something as a rogue, a rogue effort. And so, although there is, of course, always the possibility of a rogue effort, it seems to those of us working on the diplomacy that it's much more likely that nations that want to speak out and champion a new plan would gather together other nations rather than try to do it on their own, because that would protect them diplomatically and economically and security wise. And so you get this conglomeration of a few countries attracting more countries, and then eventually the European countries, North American countries come in to support it as well. After some years down the road. So that's how we actually see it working out most likely, is not a rogue. But you always have to be prepared for a rogue possibility. And the US is already monitoring the atmosphere to determine whether any country is doing any spraying of aerosols into the stratosphere. It's easy to tell. It's easy to detect
Interesting.
that
Now
that
there's
that
individuals
yeah,
actually saying that they're
yeah,
doing it. I doubt they're doing it in sufficient quantity to
yeah,
really matter, but,
Yeah, I think
that's right.
I just saw an article about the possibility, some billionaire could just decide to do this on their own. Is right?
Yeah.
Yeah.
Oh, yeah. There's a great book that just came out last year, Termination Shock, about a Texan billionaire who decided to do stratospheric aerosol injection on his own. It's a fascinating sort of scenario of how a billionaire may try to do this.
Wait, this
It
is
doesn't work
fiction
out
or non?
well.
Is it fiction or nonfiction?
It's fiction. It's fiction.
it's
Oh,
Yeah,
fiction,
yeah,
but,
yeah.
oh wait,
but it's
But
believable
what was
because
the name of the book? I gotta write this down.
it's called Termination Shock.
Termination Shock.
Termination,
Okay,
yeah,
got it.
yeah, and
That's
it's a
interesting.
really good
yeah,
sense
that's
of the
just not
whole.
the way to
Yeah,
do it. We don't want a billionaire doing this. We
no,
wanna no, I mean, no, it's just
I
not a good idea.
and
Uh,
the point I think that the book brings out is that a billionaire is not going to be able to do it without government consent. There are so many ways that they can be shut down, you know, and so it's really quite fictional that a billionaire could do it on their own. What we need is a global community of consensus around this idea that we need a comprehensive approach. And once we come to that conclusion, then it opens up a whole vista of possibilities of how we can approach it.
Okay, I'd like to wrap things up. Mark, anything more you'd like to say before we wrap up?
no, I think this is fine.
And
Yeah.
Dennis, anything else for
Yeah,
you?
yeah, yeah. No, I think that your listeners, if they are interested, to look up Healthy Planet Action Coalition on the web. We would very much welcome, their joining us. It's very easy to become a member and to participate. It's a volunteer organization. It's all volunteers. We have no paid staff. And it works on the passion and the science of our community. For example, our chief scientist is one of the eminent NOAA scientists of the last 40 years, retired now, and guiding us on all of these scientific questions. And we affiliate with all the people in the research community who are interested in this topic. Yeah.
And for the uninitiated, NOAA refers to the National Organization of Atmospheric. Wait, I don't even think what is it? National
Uh,
Organization of uh-oh,
atmospheric
something.
Yeah, I don't know what the
administration,
other A is.
Oh, it's the
administration,
it's the
atmospheric
national. Oh,
administration.
no, it's
Yeah,
the National Oceanic
oceanic
and
and atmospheric administration.
Atmospheric Administration. Okay, of the United States.
Association.
Right.
Yeah, that
Okay.
sounds right.
Yeah,
All right.
yeah,
Yeah.
yeah.
All right. Well, thank you both. I just want to say one or two things just to wrap up, which is, Dennis, you did an outstanding job of making a difference the way with how I look at this. I have been a
Mm,
skeptic of the whole climate issue for about 25 years, and I would say that and if you're successful in whatever international agreement to try to do this geoengineering, that seems like such a better concept than trying to get the entire world to cut back on emissions. It seems much more feasible. It seems much less costly, much less risky, and the kind of
uh,
thing that you could change if it wasn't working.
yeah.
I did not expect to have that reaction,
Uh,
and I'm maybe I'll wake up tomorrow and I'll be like, Ned, what's wrong with you? Anyway, but I did have that
well, you're
reaction, and I really want to acknowledge you for doing a very effective job. And Mark, thank you so much for being the devil's advocate in this episode. I think you did an outstanding job, and
yeah.
it's possible that either or both of you could be on future episodes as well. I just want to put a plug in for the Climate Verso podcast. This is still a relatively new endeavor. This will be only the third episode that we actually publish. I'll know I'm successful with this when I have scientists coming to me saying that they want to be on the podcast because they want
Mm,
to talk to their adversaries, to their opposite numbers. Uh,
mm,
I think it's bizarre that people who have strong opinions don't want to talk to people with the opposite opinions. That's where we learn things, is from having those conversations.
absolutely.
This is the third episode. There are two previous episodes of Climate Verso that I think the audience would find very interesting. And you can find Climate Verso on YouTube. You can find Climate Verso on any of the podcast platforms. And I'll say thank you again, and we'll wrap this up.
Thank you for
Good
bringing
night,
us
Mark,
together,
and
Ned.
good morning, Dennis. Okay.